Hello and welcome to the OLM Dev Working Group. Today is Thursday, April 21st. On the agenda today, we have several discussion topics centered around the V2 APIs. This is sort of a free-for-all conversation where we're just going to explore some ideas that are relevant to some of the ongoing development in OLM V2. So anyone should feel empowered or feel free to speak to the topic and any questions they may have, as we basically just try to have a, like a high-level conversation on some of these design topics. So the first topic of conversation that we have today is essentially around cluster scoped catalog source APIs. Right now in the existing OLM system, the catalog sources are all namespace scoped. And in the new V2 world, where some of these APIs are sort of implicitly descoped, it may be desirable to have the catalog source API be cluster scoped as well. But doing that has some implications for users who are used to the existing namespace API. And so one of the things we can talk about is, what does it mean for us if we introduce, us being the project operator framework, if we introduce a catalog scope, catalog source API at the cluster scope? What does that mean for, what are the benefits and what does that mean for existing users of the existing catalog sources? So I think that we can pause right there and see if anyone has any comments on this particular topic to kick us off, I guess.
So Dan, one related question I think we could also ask is, given our like descoping design plan, what would it mean if we didn't introduce a cluster scoped catalog source? Like what would the UX look like if we just use namespace scope catalog sources? And would it still make sense from like a user flow perspective? And would there be like an intuition you could have about namespace scoped catalog sources in a descoped world? So I haven't thought about that too much, but I think that's definitely like that for me, like that's part of the motivation for why we would want to do a cluster scoped catalog source is the intuition that a namespace scoped catalog source would be confusing or wouldn't work for one reason or the other. But I don't know if I've thought too much about what those exact reasons are.
I have a very strong feeling, and I wasn't in the room, but I have a very strong feeling that the reason that the catalog source API is namespace scoped is specifically because of the tenancy model, right? Like this is to enable the idea that I'm a namespace admin. I want to install an operator in just my namespace that only knows about my namespace, and I want all the permissions to be able to do that. So I create a catalog source scoped to my namespace so that I can just resolve the stuff for my namespace, and that's it. And I think that functionally that falls down basically immediately, because having permission to create a catalog source on a cluster is an escalation path to cluster admin access, right? Because all you have to do is give it the right set of, put an operator in that catalog that has the right set of permissions, and OLM will grant them for you, and then you can use that operator to do whatever you want on the cluster wherever you want. Like it's basically what we've found is that catalog source create permission is equivalent to names cluster administrator. So from my perspective, I don't know that there is any value to us trying to preserve the sort of like hierarchical namespace context of a catalog. Just because of the permission problem. Like I think it's a rabbit hole that we'll never find success in. So that's my perspective.
Yeah, I guess the other aspect of this is like in the context of RuckPack / some new APIs existing for handling cluster scoped catalog sources and existing OLM running on the cluster at the same time. Do we think that it will ever have a use case where we want, RuckPack Depi or whatever to be able to consume the existing catalog source API?
Right, and potentially vice versa, where users. I was thinking about the other scenario where users in the existing, using the existing set of APIs would want to consume a cluster scope, a catalog source as well.
So I guess, oh, sorry, I didn't mean to interrupt you.
No, go ahead, Gavin.
I guess the only use case I can possibly see for this is like a migration one, right? Like I have a cluster, it's got a catalog source on it. That thing is perfectly fine, but I want to be able to install the operators in that catalog with the newer stuff. I guess that seems like a reasonable path, but I don't know if our answer to that should just be go create another catalog source that points to the same image and then you get that content, but it can resolve for RuckPack. I guess the other question I have in the other direction is, will existing OLM be able to look at cluster catalog source as an API in order to get content? Or are you always going to have to run 2 copies of your catalog if there's some stuff that only works with existing OLM or whatever, right? Because the tendency model is not there. And then there's other stuff that only works with new RuckPack, and you want to co-locate them in the same catalog.
I think that's a like a migration problem. I think the catalog source as it exists today in a namespace scope doesn't mesh with cluster scoped resources like this. It actually exemplifies the problem we have today of this sort of friction of a mismatch. So think about the global catalog source namespace. So it's a namespace resource that's available to all our namespaces. And now you have all sorts of like collisions and problems with that global catalog source colliding with things in your namespace or not. Going a little bit further, it almost makes me question whether there needs to be a resource on the cluster that represents a catalog of content. Like you could imagine a world where whatever APIs we come up with for Depi are just pointing to an image or some remote location. There's no abstraction in front of a catalog source to pull on cluster. It's just literally like the thing that's doing the resolution says, let me point to this remote location for the catalog. And then that's the thing that handles like caching all the content and pulling it. Going even further, it seems to me like the catalog is just a bundle of bundles. And we've seen potentially situations where we could define it as such. So use the composite pattern for catalogs and have it be a bundle of a like a catalog type that you pull in. So use that same abstraction to source the content to the cluster. So
Yeah, Nick,
just
I've definitely also thought about using the bundle abstraction for catalogs too. I do think there's one nuance, which is that it seems like there are use cases. I don't know which forms we've talked about this in, but if we haven't talked about it here, then I'll just repeat it. It seems like there's use cases for like attaching metadata on things other than bundles that are relevant in the context of a catalog. So the one use case that we're thinking about is a package author saying, hey, I want to deprecate this package or mark it as, don't use this anymore, and then provide some sort of pointer over to a new package or, just some human readable message that says what to do to migrate. And then the same sort of thing for channels too, right? So you used to have a channel named Alpha, and now you renamed it to Candidate, and you want to give people a way to know how to go tweak whatever it is they need to tweak to migrate from Alpha to Candidate, for example. So I think if we went down the path of only ever kind of having a composite containing bundles, we'd lose out on the ability to have other like package or channel level metadata attached. So I think we need to consider how that kind of thing would fit in.
I'm not sure that that's the set in stone consequence, because at the end of the day, the thing that's getting pulled onto the cluster is just a container. Like what more is a bundle but a directory in a file system that the provisioner knows how to read. And so like, depending on the metadata that's there, it could switch off on what to do.
Yeah, I think I see what you're saying. You're basically saying like, what I'm saying we need to exist in a catalog can just be a different bundle type. Like our file-based catalog, we could stuff that into an image and say, oh, this is a file-based catalog bundle.
Yeah, exactly. And like you have all sorts of different avenues to go on from that. Like you could have like a sort of a barrel module of a bunch of different bundles within a single file system, and it knows how to figure it out from there. Like you can really, we've made this so flexible with the bundles that I think we could get away with using that single on cluster abstraction to handle sourcing any content to the cluster.
Yeah, that sounds really, so is that sort of moving away from the catalog source API in general? Treating,
I think the cluster scope stuff is the main reason why I would move away from that, but also I think it's maybe not be necessary because we have bundles, which is source content to the cluster. Catalog is just another type of content.
So would that mean that we would have a like resolver provisioner, for lack of a better term, like a provisioner that basically acts like a resolver today?
That's
if you look at the, oh, go ahead. Sorry.
Yeah, that's kind of the logical conclusion that I come to, and I kind of imagine like if that's the picture that you have in your head, then the input is a set of inputs and a bundle that contains the catalog that you apply your inputs to, and then the output is another bundle, maybe that's like, this is like the resolve set bundle concept, right? So
yep.
The output then is just another bundle that contains a whole bunch of bundle instances in it, and that's the thing that we want RuckPack to go and provision those up. Like those other bundle instances in that resolve set bundle are the operators that should be applied based on the resolution.
Got it. Okay.
But you want to have your mind blown even more?
Sure.
So so I was just thinking about this the other day about the inputs for resolution, and I was sort of coming to the conclusion that what is a resolved set of bundles on the cluster, but a catalog that has been whittled down. So a catalog, we could define it as a bunch of bundles to install, and all of their constraints and properties that are potentially that don't whittle it down to a single set of operators to install, like a one for each package. I mean, you could potentially say that catalogs and resolve sets are exactly the same thing, except the resolve set is just a subset of the larger catalog that's been whittled down to have certain properties. So this is a little abstract, but it might have an impact on the inputs and outputs to resolution and how we view it as an API.
I think that makes sense, Nick. It seems like if we do that, which I think is an interesting thing to explore, what we're basically saying is that like the full catalog, the provisioner for that is the resolver, but for the whittled down catalog, you use a different provisioner, which instead of coming up with a even more whittled down catalog, it just applies that, right?
Yeah, and there's like a constraint for like being applicable or not, which is that there is only one. It's like you just add another constraint to the package that goes only one per package can exist. And then that should just prune everything else out of the catalog. So I guess the input is a catalog with a bunch of constraints that hasn't been reduced yet. And then you go and you reduce it. And it drops everything that doesn't work.
This is super interesting. The one concern I think I'm imagining from all of this is that we're kind of folding everything into a single API, like called bundle and bundle instance potentially. And from a UX, like understand, like having a user understand how things relate to each other, it potentially becomes more difficult to like mind map that, because like you do kubectl get bundles and it's like they're all there. How do you know like which ones apply to which other ones? And I don't know, I guess I feel like it can be good to have different types just so it's easier to explain this type does this and this other type does this and this third type does this. But I don't know. I guess we'd have to see it more concretely to make judgments about that.
Yeah, I think there's probably still room for like a thing that tells everything to resolve, but I was thinking more from the input and output of like a command line resolver, where like the input is a catalog blob and the output is just like the reduced catalog blob, you know?
Yeah, totally. The other thing, I think we talked about this a long time ago, but the other thing I've always wondered is the resolver is a SAT solver, and there are potential like multiple, there are ways that you can satisfy the same problem in multiple ways. And like, I think right now we basically have heuristics that picks the best one based on, you know, things we decide, like always pick highest inver or closest to the channel head or whatever it is, right? But it gets even more interesting when you say, like, because we also have heuristics like, oh, if you have a dependency, then pick it from, you know, the same catalog source, otherwise pick it from another one. I wonder if there's a way to make that a little bit more transparent or extensible, such that like you kind of have stages of resolution where the first stage says like, here's all the choices. And then there's a second stage that picks from those choices or something.
Yeah, I definitely think that like we want to unify all. So if you think about it from like the reducing a catalog blob perspective, if you just union everything, like all of the blobs from all of the catalogs that you want to have information from, and then you dump them into a thing, you reduce it, all the, it comes down to, a set of choices, and then there are probably some more constraints that you can add to narrow down those choices, like make it deterministic. That might get unwieldy from UX perspective, but I think that's my general intuition of where to go.
Yeah, okay. Super interesting. Thanks, Nick, for bringing up some of those ideas you had. Do we feel like we want to continue talking about cluster scope catalog sources? I think we have some other topics on the agenda as well.
I think we can probably move on. I would probably say one of the avenues we should go look at then is, can we build a bundle type for catalogs and then a provisioner that knows how to read and consume that, right? And then we can always say later, like, okay, well, let's just, rather than calling this a FPC bundle type, we'll just call it a cluster catalog source, and we can always kind of pivot if we think we need to.
Okay, yeah, I think we can capture that in a GitHub issue. I can take that as a follow-up to sort of spec that out. Okay, so next on the agenda, we have a topic around embedding bundles in the bundle instance. This is a new feature that we've been working on in Rockpack in the 0.3 milestone. Essentially what it does is it allows you to enable, like it sounds, a bundle spec inside the spec of the bundle instance. Right now we have a workflow where a user creates a bundle, then they create a bundle instance where they explicitly refer to the bundle by name, and there's sort of two disjoint objects. What this feature enables you to do is to create essentially one object, just a bundle instance that has the bundle embedded in it. If we implement this feature and we remove the spec.bundle name field from the bundle instance, basically saying you have to embed a bundle in a bundle instance for it to exist, for it to be active, we sort of lose some of the decoupling that we have now, but we get like a more ergonomic workflow. So I guess it's worth thinking about whether we want to preserve the existing behavior, or we think that this new tweak to the API is actually more desirable, and we don't need to have the existing behavior where you create the bundle separately up front.
Yep. My naive instinct is that it's much nicer to have it embedded. And I think that's what we should do. And then, if that turns out to not be the right answer because we run into some problem with it, then we can always again revisit. But yeah, it just seems like it would be so much nicer to be able to just say, like, here's what I want, make it so with one object. The one thing that we were discussing a little bit was that you lose this like audit ability potentially, which is I want to create the bundle, see what its contents are, and then decide after that I'm going to create a bundle instance that references it and make it active. And we talked about a couple of options. If we one option would be that you could have like a Boolean field in the bundle instance called like active or not. and then you could set that to false and see what the bundle looks like. The problem with that option is that if you're going to do like a bundle pivot and you want to see what the new bundle looks like, you don't want to set that thing to be inactive because then you basically uninstall everything. So that seemed like it was a little bit of a non-starter. There might be some tweaks you can make there in terms of like, well, don't apply my new bundle yet. Unpack it, but don't apply it. But that like starts to get pretty weird from a UX perspective, I feel like. So we kind of discarded that as an option. The other like obvious workaround is like, well, you can go and still create a bundle separately and look at it. But if you want to actually apply that bundle, like you're going to have to create a bundle instance that references that same spec. And then you might end up with a duplicate bundle on your cluster. But you still have like, there is a way to go and inspect that beforehand. So that's kind of where we ended up is let's just put it in the bundle instance spec. And if you need some sort of audit workflow, you can create the bundle separately first, inspect it, and then create the bundle instance afterwards, duplicating the bundle. So I don't know if anyone has any more thoughts on like this audit use case, whether that's a real use case or not. We couldn't come up with anything super definitive other than like the Android style permissions pivot decision kind of thing, which in my mind probably doesn't live in the Ruckpack layer at all. So I think it's probably okay to ignore it. But that's certainly debatable.
Yeah, I think we may want to focus a little bit more time on that particular use case. I'm not sure that it's super important to be able to see the resources on the cluster when you can just pull the bundle yourself and sort of extract it. But like you said, you also have that separate bundle stuff. I was also thinking that like a lot of this could be handled with like a policy engine and validating webhooks. Maybe there's something that sits on top of bundle instances.
Yeah,
right?
we talked about that a little bit. The problem I think with validating webhooks for like bundle instances is that like what you really want to do is inspect the contents of the bundle probably. But to get that bundle to exist on the cluster, like either the validating webhook has to implement a whole bunch of logic to unpack it itself, or you've got to let that thing go through such that you see the bundle get unpacked by the bundle instance controller, but then by then it's really too late.
I mean, you still have the same problem with the like normal label selectors, right? Or the original mapping, I guess you use a name now, because you can potentially create a bundle instance today without the bundle existing first, right?
Yeah. I guess you could do something. Yeah, you could do something a little smarter there potentially, which is like you can't create a bundle that already has a bundle.
Hasn't been
right
built and unpacked.
Yeah, but that sounds complex too. So I think my stance at the end of the conversation we were having in the last couple of days was basically there is no concept like this for pods and deployments. Like if you want to inspect the pod, you go and look at the contents of that container image before you apply it to the cluster. And maybe there's like we have the bundle image ref for the git commit ref. Like, so maybe there's a database of something somewhere that says like, oh, you want this container image. Well, I'll go look it up in, my database to tell me whether I can accept it or not. But that's kind of a reference. Like that database is more of a reference for like what actually the contents of that thing are. And it's just a representation to let you make a decision without actually having to know the content, which I think is similar to how like the some of the pod validating webhooks work, right? Like where you can say like, oh, well, deny this pod because it's not in the right registry, or deny this pod because I looked it up and its image has a security vulnerability or whatever. So you can imagine doing the same sort of thing for bundle images.
Tyler, go ahead.
Yeah, I had a quick clarifying question. What exactly does embedding the bundle instances provide us that is a better user experience? Because if I run it through in my head, the main situation that this would be useful is if a user is trying to manually create a bundle instance. And as I understand it, in the future, there would be an input API that would be sitting in front of this. So I'm wondering if this work will get invalidated by the bundle of bundles, or sorry, the catalog thing that we just talked about a moment ago, or a catalog source API. I'm kind of curious if this work would be overwritten by that.
I think what we don't want to do now is have the exact same requirement for resolution that we do today in most cases. Like, it's pretty annoying to you can't install bundle today in OLM without doing resolution. Tomorrow, that's not necessarily going to be the case.
Oh, okay, I see
And-
where you're going with that.
yeah.
Yeah, that makes a lot of sense. I think that was mainly a clarifying question for myself, so I appreciate it. Thank you.
The other thing I would add is that, like, right now, if you look at all of our docs, like, they all say, like, create this object and then create this other object. And what this change would do is it would say, like, we'll just create this one object. And then the controller for bundle instance knows how to go and do all of the work to get that original object created on your behalf. So it's just a much nicer user flow because they only have to create one thing.
Okay, and then my follow-up question to that is, at the end of the day, a bundle instance is really just a wrapper for a deployment, if I'm understanding that correctly. Not a wrapper, but like an abstraction equivalent to a deployment, where the bundle instance goes and creates the resources. Similar, a deployment goes and creates the pods. In a deployment, we reference an image. So too, it would also make sense that in the bundle instance, we reference a bundle. And so to me, I think that the abstraction is a natural one. And so I was curious if it makes sense that under the hood, we just go ahead and create a bundle using like a bundle, like we just go ahead and create a bundle out of that spec there. And then what that gives us is the bundle reconciler goes ahead and runs that loop.
Yep, exactly. So basically, like, the bundle controller as it exists today, like, doesn't change at all, right? The only thing that changes is, rather than asking a user to go and manually create the bundle spec, we tell them to embed it inside the bundle instance, and then the bundle instance controller says, oh, okay, I'll go create that bundle object for you. I'll make it owned by this bundle instance such that when I delete the bundle instance, all the bundles that were referenced ever get cleaned up. And then that's also nice from a potential pivot standpoint too, because then you can say, like, so you could think about the workflow of, I create a bundle instance pointing at version 1 of a bundle, and then I go and edit that bundle instance to point to version 2. So what you would imagine happening is, like, to do a pivot, the bundle instance controller creates the version 2 bundle, tries to pivot to it, and only when it's successful does it go then and delete the version 1 bundle. And there's probably some area to debate about exactly how that works, but, like, that's kind of the high level way that a deployment works, right? Where, like, it does the rollout, and only when the rollout is successful does it kind of scale down the previous replicas.
Okay, I think I'm following. Thank you.
Yeah, that's a nice observation about the owner refs being placed on the bundle during pivoting actually being potentially advantageous. That is one of the other things that changes, is now that the bundle instance and the bundle APIs end up sort of more coupled when you embedded the bundle in the spec, which I think is something that we want. So that's positive. Okay, I feel like that was a productive conversation about embedding bundles in the bundle instance. Next topic is one of our favorites, around bundle immutability. should bundles be immutable? What are the implications for pivoting? I would say I would lean on Joe to sort of describe maybe the desirability of having an immutable bundle, like what that really gives us, and how to implement it.
Yeah, so I think my, like putting a user hat on again and kind of comparing this to the deployment pod setup. Pods are basically immutable, right? Like you can't go and change the image that a pod is running. If you want to change the image of a pod, what you actually do is you just go and create a new pod. So like in my mind, we kind of want to do the same thing with bundles and bundle instances. So if you want a bundle instance to pivot, you tell it a new bundle to pivot to. You don't change the existing bundle. And I think if we do the embedding, that actually works even a lot, like it's a lot more natural that way, because kind of that's your entry point to change the bundle anyway. But even with that, like you still probably want to make the bundle immutable, because it would be an odd situation for, so consider the scenario where we've embedded the bundle in a bundle instance, and you've created a bundle instance, and the bundle instance controller has created a bundle, and now you go and edit that bundle, right? Unless we're extremely careful, and I don't even know if this is totally possible, but I could easily imagine that we go and edit that bundle, that triggers the bundle instance to reconcile, and it says, oh, okay, like, yeah, I see you've changed the bundle, so I'll go and pivot because of that bundle change. We probably don't want that to happen. What we probably want, if you want to like change that bundle, you should go to the bundle instance and change it rather than the underlying bundle. So to me, it's like pretty natural for us to say, like, once you create a bundle, that's it. Like, you can't change it. The other kind of related piece of this is like, should we ever, once we've successfully unpacked a bundle, should we ever re-unpack it? Right. So imagine, and I think like this gets into some like interesting nuances, I think, with like how we're unpacking images. But imagine a case where like you have a bundle image that uses a tag, right? So v0.1.0. And we've unpacked it and that all looks good. And now we go and like change the label on the bundle for whatever reason. And so we re-reconcile that bundle. But in the meantime, the image has been changed to a different SHA. So the question is like, well, should we go and re-pull that bundle image content and then have the bundle instance controller pivot to that new content at that same SHA? Or should we always basically treat the bundle, like the original unpacked bundle content, as like the only bundle content for that bundle? And in my mind, like if you're looking at how pods work, there's no piece of the pod or kubelet machinery that like repulls the pod's container image and restarts the pod when the SHA changes, right? Like once you start the pod, that's it. And if somehow the underlying node image file system gets corrupted, like I haven't actually tested this, but my assumption is that like the pod dies, crashes, and says like, sorry, no more pod, and you get like a completed error or like a crash kind of thing. And if you have a deployment sitting above that, then it'll try to start up a new pod, and at that point, then you're going to potentially use whatever image pull policy exists. But like that original pod like never gets well, maybe the original pod gets restarted, but you never re-pull the image for it, right? So I don't know. That's kind of my brain dump for where I think my head is at for like bundle immutability and whether we should re-pull bundle content after a successful pull. But I'm sure others have thoughts too.
Yeah, I think on the second note around whether we should re-pull or not, I also agree that it's potentially more desirable not to update the bundle contents if the underlying SHA that's being referenced changes. It feels like not very native Kube-like to do things like that. I mean, it's hard to come up with implementation that is like robust in that sense. So I think I agree with you there on whether the bundles themselves, whether the immutability as you describe it is something that is really necessary. I guess we would have to, if we wanted to make them immutable, we would do that like pretty soon, and we wouldn't want to change it back, right? Like it would be kind of like a pretty definitive step in terms of the API. So it's worth thinking about. I guess we can always change everything now that we're sort of in the alpha stage, but just pointing out that it's a pretty significant design move to do that.
Yeah, I think from a intuition standpoint, I would say let's go ahead and change it to immutable. I think the logic for knowing whether or not to repull the bundle is going to be slightly more difficult because of well, I guess basically what we have to do is say, like, we're going to store that bundle image content somewhere, and the next time we reconcile, if we see that it's already stored, like, we won't ever try to repull it again. I guess that's how we'd have to do it, but those are all implementation details. I feel like we should do both of those things though. And then and we can do that now, we can change that. And if for whatever reason that falls down for some piece, then we can revisit. But in my mind, like, that's the natural first kind of stab at how that should work.
And by implementing bundle immutability, that would be in the form of some kind of an admission webhook, or is there a way to mark fields as immutable on the CRD schema?
I don't think there's a way to do it on the CRD schema yet. I think there's some enhancement proposals in the Kubernetes space, or at least issues that ask for that sort of thing, but I don't think it exists yet. So yeah, I think it would have to be an admission webhook.
Okay, cool. Yeah, so I guess maybe those are, I don't know if we have issues for this in Rockpack already. But if not, we should definitely create them and put them maybe put them in the next milestone as things that we want to address sooner rather than later, since they're pretty key conceptually to the whole API design. Cool. So I think if we're wrapped up on bundle immutability, the last topic is something that's very interesting, but also pretty abstract, and it's around a generic design for DEPI that would allow for different Kubernetes distribution version constraints. So I think as we try to sketch out what DEPI is and what DEPI looks like, it would be interesting to think about how you can propagate different constraints based on different Kubernetes providers into it. I think this is an example of something like the generic constraint type design that we want to get out of DEPI ultimately. And this is sort of just an idea, and what, you know, it's just something that we can think about. If anyone has a thought on it, then we can discuss it. I think it's fairly nebulous, but also pretty interesting.
Yeah, so maybe to provide a little more context and detail. So the idea is basically that, like, DEPI is going to be this upstream project that doesn't necessarily have any specific logic built in for vendor specific Kubernetes distributions, or whatever constraint rules people want to be able to write. But at the same time, like, we want to be able to support those different distributions and constraint rules that people care about. So I kind of posed this question yesterday, and thanks, Dan, for putting it on the agenda. I guess the question is, like, how exactly do we include how do we design it such that if you're a bundle author, which constraint types your target distributions are going to support, and what if you have a bundle that you want to support in EKS and AKS and OpenShift, and you say, okay, I depend on EKS version this and AKS version that and OpenShift version this, but when you deploy to OpenShift, like, obviously you're not going to be able to satisfy your AKS and EKS dependent constraints. So that's kind of one aspect of like this thought process. And then the other is, how does DEPI know how to go and ask that specific distribution for its constraints and or for its properties in a generic way such that they can be applied. And I know we've talked about this a little bit with the dynamic constraints, or the dynamic compound constraints and dynamic properties kind of stuff. But I don't think unless someone can correct me if I'm wrong, I don't think we've ended up yet with a solution that allows a cluster to provide more properties into the resolver for constraint resolution. So anyway, I just wanted to kind of tee this up as a sort of a little brainstorm for people to think about in terms of different implementation options.
Yeah, if we want to keep going down the everything is a bundle route, you could end. Well, I think the input API is a big part of this as well if we decide to go down that route. But with the everything is bundles route, you could put, and you had like an inline type bundle, you could put properties and constraints in the bundle as its content. To be read like as metadata, I suppose. And then that could be read by provisioners, right? With the resolver. And then there needs to be some sort of registration for different constraints. I think Ben Luddy had originally added an additional field or namespacing to some of the constraint types. I think it was called constraint engine or policy engine or something like that. That would basically identify what resolver could interpret constraints. So I think this would be like one of those star class type deals with registering that and then having an interface to call out to.
Yeah, I think one thing I wanted to point out too, I think it's basically what Nick is saying, but from the DEPI strawman perspective that we had built a while ago, where I think that we would just have input classes for different operating systems, wouldn't we? Where we would have like the ability to create different types of input classes, which is kind of a similar concept to provisioner classes in Ruckpack. And one of those could be for EKS, one could be for OpenShift, one could be for AKS. Or we could also add something to this hypothetical API where it's just a property of operating system, and then it applies like certain rules based off of that. Those are the thoughts that I'm having when this question is proposed to me.
Yeah, to me, it makes sense as like a initial pass to say like, yep, like what Nick was basically saying in terms of having static properties being provided via like a separate input kind of thing. I wonder though if that's enough. Like, do we think there's a case where we want the resolver to be able to be told to go talk to some other webhooks or web services somewhere to like bang, like hey, I noticed this class of property or constraints exist. Like, let me go ask the AKS OLM resolver, if it's okay. Like, I wonder if there's some sort of dynamic aspect of this that we think we'll need to handle at least at some point in the future. And if so, like, is there an abstraction we can build that lets us do the static thing for now, but then inject some dynamic thing later?
A potential use case of this could be something that we've seen from some of our content developers is needing to know what are the storage classes based off of their distribution. So given that EKS and AKS and various things have different storages available to them, our products tend to have to make different decisions based off of that. So that dynamic thing based off of the constraints could be used in that use case. I think you'd get dynamically, if they put a constraint about storage class, you could dynamically go query the cluster and say something about what it has. Would be helpful.
Yeah, absolutely. That's a great point. I think the minimal version of this is just depending on min kube version, which I think is accessible across all these different distributions. But then, right, we can layer on more and more different types of constraints into DEPI and the resolution system within DEPI.
Yeah, Dan,
Absolutely.
that
Sorry.
might be interesting. Sorry, go ahead.
I was just going to say it's your initial crawling stage and then build on it to get to something more elaborate in the future.
Yeah, and that might be like a good use case or like scenario to think about like making this dynamic, right? Like, we have the benefit of knowing that if we're running DEPI in the context of a cluster and we're always resolving in the context of the same cluster that DEPI is running, then when we upgrade the cluster when we upgrade the cluster, we don't necessarily get a new instance of DEPI running, right? Like, you might not upgrade DEPI when you upgrade the cluster. So that container might just keep running through that change. And yeah, like, the cluster could go and generate a new static property that says what version it is, but you could argue that you don't need to do that because you can go ask the discovery API what version it is anytime you want. So like, I think we already have like a really good example of a dynamic property that would be interesting. It would be interesting, I think, to kind of prototype out something that, like, rather than hard coding something directly into DEPI that knows how to ask the discovery API, is there like an abstraction that we could teach DEPI, hey, go talk to this endpoint for this property or something like that. And then we write some other thing that queries the discovery API and tells DEPI what the answer is.
Can it be the same thing that we use to add properties and constraints? So like input, right, that we've been talking about is effectively inject properties and constraints into the resolver with the catalog, and then come to some conclusion about what should be on the cluster and apply it. So bundles and bundle instances tell you what properties are on the cluster. So maybe, I don't know, can we just unify all of this into some singleton that tracks all of the properties and constraints on a cluster at any given time, including the ones that you're inputting, like maybe a API service with a special singleton endpoint for properties that you can just add more properties to?
Yeah, I think I'm following. it's like another layer of indirection, but I guess it's more abstract and it makes the
guess-
input API more modular, I guess.
Well, I guess what I'm trying to say is that, like, I don't know, I sort of want all of the properties and constraints that are on the cluster and that we want on the cluster to be in one place, because it's really confusing with like subscriptions and other thing that other APIs today, where like you have to stitch it together from all of these other sources to figure out exactly what the current state is and what we want it to be. If that makes sense.
Right.
That makes sense to me, Nick. I'm just not sure like how that has anything to do with how we figure out what those properties are. Like, I guess when you were talking, I started imagining that what we would do in the input API is allow you to have like to define a property or a constraint, but maybe like for properties, there's like a different strategy for property being provided, and one is like static, where you just give us the value. And this is kind of like the environment variable situation that's set up in pods, right? Like you can either say, here's the value and just put it statically, or you can do value from, and then there's some configuration for like where to get that value from. And then one of those things could be like, oh, we'll just go hit this, like get this URL, and that'll return you the value of the property or something.
Yeah, I'm trying to understand how different that is from having a place to write properties and then having some external controller write a property to it.
Well,
Right.
yeah, I guess I'm just thinking in the case, yeah, I guess that's similar, other than like that other controller then has to have RBAC on the cluster to write to that place, whereas in the get scenario, it doesn't.
I mean, like you're in the get scenario, you potentially have to set up the reverse authentication depending on what we do. I'm just like,
Yeah.
Can we make this all one place, and can we consume, I don't know, can we just consume it through the API that we already have, which is really, really loose for like, it's just a type and a value, really.
Yeah, I think that is another viable option to consider. So it's basically, what we're basically saying is like, it's either a push or a pull model, right? Like either we have a controller that pushes it to this centralized place, or we have the collector pull it from all of the places.
Yeah, but now that you mention it, I think, like we were talking about before with extending the resolver, like to discover new types of properties and constraints, we're going to have an interface anyway, like an interpreter interface where like you register something that can interpret that property as a yes or a no for the stat solver. Because we can't obviously know about all the types in advance.
Yeah, I see what you mean.
So maybe we have to do what you're talking about anyway, is what I mean.
I think that might even go a step further than what I was thinking, because what I was thinking is like, we would just have this web endpoint return the value of the property, but you're right, like evaluating that property against a constraint is also something that we might want to be extensible. Is that what you're kind of getting at?
I think it needs to be, if it's any sort of property that the resolver already doesn't already know about, it's like pre-programmed.
Right. And we do have like the cell sort of property or constraint evaluator. But I agree that it would be nice to give an extension point that lets you define your own thing, right? Like it would be nice if max AKS version was something you could put as a constraint, and then there'd be something that knows how to evaluate that with SimVer and all sorts of stuff, right?
Yeah, exactly. But the cell constraints are like really awesome. So
Yeah, the nice thing is that that's always the escape hatch now. Like, well, it'd be nice if we could name it this thing, but you can't. But like, here's a cell expression you can use to do the same thing.
Cool. All right. So that was that last topic. I think that was super interesting. So that's it. We're out of time. We're actually over time. I thought today's conversation was super, super interesting and productive. So thank you all for attending, and wish everyone to have a nice rest of their day. Thanks, everyone.
Thanks, Dan.
Thanks, Dan.